In this question, we are given the value of an equipment which declines in the form of a function. So it is given as v, which represents the value of the equipment. It's a function of time, so it's given as f of t equals v naught e power minus kt. And with some initial conditions, that is, after 2 years, the value of the equipment is $200,000, and after 5 years, the value of the equipment is $120,000. So we are going to use these initial conditions to determine the value of K and V naught. That answers the part A. And in part B, basically we have to write down the function T once we have evaluated the value of K and V naught. So we just have to substitute the value of K and V naught into the function f of t, so that we get the f of t, which answers the part B. And in part C, we have to find the time when the equipment value becomes $50,000. So let's start doing the part A. So to answer part A, we have to use the initial conditions. So let me write down here. This is after 2 years, the value of the equipment is $200,000. So I'm just going to put only 200,000 without the units, so it is understood that it is $200,000. So we can plug this into this function. That is, in place of t we put 2, and in place of v we substitute $200,000. So therefore this equation becomes 200 on the left side, that is for v, equals v naught e power minus of k times of t equal to 2. So it's basically equal to v naught e power minus 2k. So let's call this equation as equation number 1. In the same way, we have to use the second initial condition, that is when t equal to 5, that is after 5 years, the value of the equipment is $120,000. So once again, we plug this into this given function v. So when we do that, we'll get 120,000 on the left side. That is, I substitute 120,000 for v, and this is equal to v naught e power minus k times of t equal to 5. So it's basically equal to v naught e power minus 5k. So we now have two equations which we can solve for v naught and k. So let's solve these two equations. I can do this equation 1 divided by equation 2. When I do this, I have to divide both sides by I have to divide both sides, that is left side as well as the right side. So when I divide the left side, I'll be getting 200,000 divided by 120,000 equals, on the right side I have for the equation 1 I have v naught e power minus 2k, and for the second equation I have v naught e power minus 5k. So we can simplify this, can cancel these three zeros as well as this one of the zero. So this left side basically reduces to 20 by 12. On the right side, I can cancel the V naught, and using the power rule, I can simplify this as e raised to the power of minus 2k and plus 5k. So plus 5k minus 2k is basically 3k. So this becomes e raised to the power of 3k. So we now have this equation 20 divided by 2. This can simply written as 10 by 6 equals e raised to the power of 3k. So we have this equation. We have to solve this for k. We can apply the natural logarithm to both sides. So we apply natural logarithm, and when we do that, we'll be getting natural logarithm of 10 by 6 equals natural logarithm of e raised to the power of 3k. Now I can simplify this right side using the property of logarithm, that is this 3k, I can put this in front. This is by the property of natural logarithm. So this becomes 3k natural logarithm of e. Remember that natural logarithm of e is equal to 1. So I can simply replace this natural logarithm of e as 1, which means 3k times of 1 is basically 3k. So I can just leave it like this. So therefore this equation becomes natural logarithm of 10 by 6. I'm sorry, it is 10 by 6 this is equal to 3k, which means if I have to solve for k, I just have to divide both sides by 3. So therefore I can write down the k as natural logarithm of 10 by 6 divided by 3. Now we can plug this into the calculator to determine the value of k. So k comes out to be 0.1703. Remember that we have to give the value of k in 4 decimal places. So this is the value of k. Let's now determine the value of t. So to determine the value of t, we can take the value of k, plug it into one of the equation, either into equation 1 or into equation 2. So let's plug it into the equation number 1. Let me write down here. So I'm going to write down 200,000 equals, I need to determine the value of V naught. So I put V naught e raised to the power of minus 2 times of k. Let's recollect the value of k. It is 0.1703. So I can replace k as 0.1703. So this is equal to V naught e raised to the power of, we can multiply these two, and when we multiply these two, we'll be getting 1703 times of 2 is basically equal to 0.3406. Since it is negative, I write down this as e raised to the power of minus 3.406. We can also calculate this value using the calculator. So we can plug it into the calculator, and when we do that, we get the value of e raised to the power of negative 0.3406 as 0.71133433. So it's just a repeating number. So this side we have 200,000. Now we have to determine the value of V naught. So therefore V naught is basically equal to 200,000 divided by this quantity, that is 0.711343. So we can plug this into the calculator, and once we do that, we get the value of V naught as 281,158.16. I have approximated to the 2 decimal places, since we have to give the value of V naught in 2 decimal places. So basically we have answered the part A, that is we have found the value of k and V naught. Now let's answer the part B. It's very simple, that we just have to substitute the values of k and V naught into the function f of t. So when we do that, I can write down here, we get the value of or the function f of t is equal to V naught, that is 281,158.16 e raised to the power of, we know that the f of t is e raised to the power of minus kt. So replace k with 0.1703. Therefore this will become minus of 0.1703 times t. So this is the function f of t. We now answered the part B. Let's now answer part C. So part C basically asks us to determine the time when the equipment value becomes $50,000. So which means we now have this f of t. So we have to replace the value of f of t as 50,000 and then determine the value of t. So I am replacing f of t, that is v or f of t both are same. So I'm replacing f of t as 50,000. This is equal to 281, 158.16 e raised to the power of negative 0.1703 t. So it's basically this involves some algebraic calculation. So first we have to divide both sides by this quantity, that is 281,158.16. So therefore this will become 50,000 divided by 281,158.16. This is a comma. This is equal to e raised to the power of minus of 0.1703 t. Now to determine the value of k, that is t, we can apply the natural logarithm to both sides. So when we do that, we'll get natural logarithm of 50,000 divided by 281, 158.16. This is equal to, remember that we have already applied the property of natural logarithm, uh, as I can show it here. So we get like this, that is natural logarithm of e raised to the power of some quantity. We get only that quantity. So we can apply that over here. So when we apply the natural logarithm to this side, that is to e raised to the power of minus 0.1703 t, we are going to get only minus of 0.1703 t after using the property of logarithm as well. Now we can determine the value of t. We just have to divide both sides by negative 0.1703. So let me do that. I'm going to divide this by this left side by minus of 0.1703 t. I'm sorry, this is not t here. So this side we simply have t. So this is the value of t. Uh, we can plug in all these values into the calculator, that is natural logarithm of 50,000 divided by 281 comma 158.16, and then once again we have to divide that by minus 0.1703. So when we do that, we get the value of t is equal to 10.14 years. As we have to give the value of time in two decimal places, I have approximated to 10.14 years, which means we have answered the part C as well. Part B we have already answered.